Good evening, everyone. Okay, so mm, okay, so let's start today's session. Right. Today we are going to discuss about class and objects. Right. So there is a very, you can say, a theory, uh, programming paradigm, right, which is particularly known as OOPS concepts. Okay. Okay. So basically, there are four pillars of OOPS, four main features, four main, you can say, functions of OOPS, right? One is encapsulation, another one is abstraction, one we have polymorphism, one we have inheritance, right? Okay. Okay, so let's first discuss about these two, encapsulation and abstraction. Both of them are purely theoretical based concepts, right? Those are a, yeah, Vishal, what is your doubt? Put that on the chat, right? Okay, so basically encapsulation and abstractions are, you can say that, concept, purely theoretical based concepts, right? Give me a second, just guys. Yeah, okay, so let's continue. Okay, so let's first talk about abstraction. See, from day one we are using abstraction, right? Suppose there is a boundary, a border, right? And behind this border there are multiple functions are written there, right? Like your printf statement, your math.sqrt function, your dot split, dot strip functions are there, right? And as a user, what we are doing, we are just calling these functions, we are calling these functions, right? And using them, just it, right? That's our job, right? That is what we are doing. Suppose, for example, if suppose you have a list, and all list contains only integer, right? In this case, if you want to calculate the sum of each and every element, you have to just call the sum function, right? And you have to just print the total. You will get the total. The Okay, give it a second. Yeah. So you will get the total. Now the implementation of this sum function, some for loops were running inside this function, some calculation are done inside this function, right? So how this function works is, right, we are not concerned about how this function is working. Our work is just to use that function. We know the use case and we are just using that particular function. So this is known as abstraction. So a particular definition for abstraction is hiding the implementation. The implementation of that function is hidden from the user, right? We are hiding the implementation and we are only using, okay, so and we are only using the particular function and function calls, right? We are only using that function. We are not concerned about a particular what that function, how that function is implemented and what is written inside that function code, right? So this kind of hiding things, right? Coding paradigm, this is known as abstraction, right? Hiding the implementation and providing the necessary data. That's it, right? Consider this sum function call as your necessary data. This is your necessary function call. It is given to the user, right? But how this function is working, how this particular function is working, it is hidden from the user, right? So this is what abstraction is, right? Okay, now what is encapsulation? So see, last day we have seen that there are global and local variables, right? So suppose we have created a function, okay, and inside this function, suppose you have multiple variables. There is one variable, there is the second variable, there is a string variable, there is some list variables, right? And inside this function, there is again, consider that there is again a small function written inside your function. Okay, consider an example like this. Suppose I have an example function, and suppose I have a string variable. Okay, I have a list variable. Okay, now inside this, suppose I have a one more function, and inside this function some codes are written. Just leave that part, right? So see, so you can observe that this particular function, we have this particular function, this parent function is acting like a box. Okay, this parent function is acting like a box, and each and everything is inside that particular box, right? So this type of concept where related things, right? Related things, by what I mean that some string variable is related to some list type. For example, in this string, you are storing the name of a student, and and inside this list, you are storing the marks of that student, right? So both are interrelated with each other. Suppose inside this function, what you are doing, you are calculating the total marks of your students, or calculating if the student is passed or failed, right? So in this particular scenario, when a single box contains interrelated variables, interrelated functions, this type of implementation is known as encapsulation. So the definition for encapsulation is that in so encapsulation, the proper definition will be binding all related attributes, I mean all related variables and functions under one single name. See, this string, this list variable, and this particular function, all are local, all are only present inside parent, right? So consider parent is a very big box. Okay, this parent is your box, and inside that box your variables and functions are there. Okay, so uh, containing, or you can say that creating a particular box and containing all related elements inside that box, this is known as encapsulation, right? We can get to the proper meaning of encapsulation once we have discussed about class and objects, right? Okay, now see, so we have discussed about encapsulation abstraction. We will see what polymorphism is, right? We are not going to discuss about inheritance because inheritance in itself is a very big topic, right? Okay, so first of all, how these OOPS concepts are implemented, right? So you can see that this parent, this particular function is able to create a encapsulation type of thing, right? But there are many more concepts other than encapsulation, that is abstraction, polymorphism, inheritance. You can also see that abstraction is implemented using a function, right? We have seen that, see, the print statement, it is abstracted from the user. The implementation of print statement is here, right? The code for the print statement is written here, but we are only using the print statement to do our job. That's it. We are not concerned about what the code is and what is written in the backend, right? So this is again abstraction, but it is a function. So there is one more concept, one more type of, you can say, class and object as a data type, where you can implement, which is used to implement the proper concepts of OOPS, object oriented programming, right? So first of all, let's see the practical, I mean, let's see the implementation of class and objects, then we will see, discuss about the theory part, right? So first of all, we have class and objects. Now, so what is the particular syntax to write a class? It will be class keyword, name of your class. You can provide a small parenthesis, it is optional, right? Inside this, just provide the particular, suppose you are a student, so you are creating a software to uh, store the data of a student, right? So what type of variables you will need? You will need a name, right, to store the particular name of the student. Okay, what else do you need? We need the university name. Okay, we need a list to store the marks. Okay, let me provide them string, empty string only. Yeah. Okay, we'll just leave things. So this is what we need. Okay. Now what else do you need inside your class, your particular class? I mean, what else you need for a student? So suppose you have to check if the student is passed in his subject, qualified for each subject or not, right? In that case, what we need a function inside a class, right? Okay. So this particular function, suppose we have pass fail function. We are running a for loop in our marks list, and if element is less than, suppose less than 50, then print that the student is failed, right? Consider it like this. Now in this case we are getting some errors and some warnings. Okay, so let's get into the explanation part. So now what is a class? See, whenever, see, if I have created an integer of value 10, right, and if I will print the type of this variable, the type of this variable, it will print int, but instead of int it prints class int, right? So now let me tell you what is a class and how it works. So suppose, what is the size of an integer? The size of an integer is 4 bytes, right? So suppose what we are doing, we are creating a variable a, right? We are creating a variable a with some value, suppose 1, value 1. We are creating a variable. Now, how does the interpreter, how does the Python handles this? So what this Python will do, it will create a memory space of 4 bytes and it will store the particular data there, right? Now here a questions come, how does the interpreter knows that the memory size will be of 8 byte, and how does the interpreter will know, the compiler will know, your system will know that the value is exactly 1, not other than 1. How this value is migrated from here to your inside your memory, how it is done, right? So what happens, there is, suppose there is a blueprint, right? A class, integer class. Let me show you. So, okay. See, this is an integer class, right? What is a class? So for class, you can say that. So what is class? So class is the blueprint and object implementation of class, right? Okay, now let's see. So this integer, this whole class, this integer class of whatever 100 or 104 lines. Yeah. So it is of 104 lines, right? So this whole integer class, it defines that, right? It is a blueprint, the blueprint of this memory location, how interpreter will create this memory location, how this data is going to be migrated, what will be the size of this memory location, how to delete this memory location. Each and everything is written inside the class, is written inside your blueprint, right? Everything is written inside this integer class. If possible, let me show you the implementation also. Okay, these are the functions for that. Okay, if you can see that there is a byte function here. So the you can I think everyone of you are aware that our system, our computer stores data in 0 1 format, right? So what does this class do? It will convert your one to a particular byte format. It is generally known as byte string, right? And then these bytes are stored here inside the memory location, right? Okay, so okay, just leave that part. So what is class? Class is the blueprint, right? Blueprint of how to create a memory, how to store data, how to delete a memory. All those things are written inside the class, right? Now, this particular A, okay, this particular A, our variable, this A is known as the object of the class. See, the name of this particular memory is not integer. The name of this particular memory will be A, right? This memory is referred as A. So if you want to print the value, if you want to print the value, we are not printing like this. We are not printing int, right? We are using the name of that particular variable to get the value. So what is this variable? This variable is the object of your class, object of your integer class, right? So consider it as class as the blueprint and object is the implementation. Now let's go through it again, right? So what we have in our hand? We have a blueprint, right? And what we want? We want some memory to be created in RAM, and that memory should store whatever value we have, suppose 1 and 2, whatever that is. So how it happens, right? First of all, we create an object, right? First of all, we will create an object. We will assign some value to this object, right? Now, what an interpreter will do? Interpreter will receive this object, right? Okay. Now this object refers to this particular class, right? So interpreter will check the blueprint of this class. What does this blueprint states? What will be the size and all those things? And after checking that, interpreter will create a particular memory for you to store the data, right? So you can consider an object as the implementation of a class. Object is implementing the class, right? See, okay, before this, see, if there is no A, if there is no A created, then there is no memory created for that, right? It is a very, you can say, crucial point to understand that if no object is created, then there is no memory created for that class. This class by itself has have no memory of its own, right? So you have to create a object, right? Object with value, okay? And I am providing some value to this object. Now what the interpreter will receive, it will receive this particular A with value 1. What the interpreter will do, it will check the particular blueprint and it will create a memory for that variable and store that variable inside that, store the values if some value is provided, right? It is not necessary to provide a value, right? If I will provide only int, so it will create an empty, see, it will create an empty integer type and the value will be 0. Okay. Now, so let's talk about these. Now, how to create a blueprint? I mean, how to create a class, right? So, first of all, Let's consider what we are building. We are building a class to store student data, right? Our requirement is to store students data, right? Okay. Now, so we have to create some attributes. Now, guys, there are some technical terms used here. These types of variables are termed as attributes in a function. Okay, these are termed as attributes. And functions are known as methods inside a class, right? For a particular class, functions are known as methods and variables are known as attributes, right? Okay. Now, so we have to create a class, we have to create a blueprint to store students' data, right? Now, if you want to store student data, we need some different types of attributes, some different types of variables. Suppose we need a student name, we need the university name, right? What else we have? We need a list to store. Okay, so we need a list, right? So we need a list to store data about student marks, right? So all these attributes are created inside the class, right? Again, we also need one more thing, and that will be we need a particular function, a method, right? So, okay, now let's see how abstraction and all those things are implemented here, abstraction and encapsulation. See, all these data, each and every data provided inside this class, the attributes, the functions, each and everything, all of those data are there inside one single name, one single box, right? That box is our student class, right? This particular box is our student class, right? Okay, so encapsulation is implemented. Now, we will discuss about abstraction once we create the object for this class, right? Okay, so first of all, let's comment out this and let me create an object. So this is a standard procedure to create a object, right? A syntax. See, first of all, see, when we do a is equal, okay, just leave this one. When we do b is equal to 10, right? So integer is a built-in class in Python, right? It is already provided by the Python. So it is a built-in class. So these type of assignments are already, you can say that, handled by the Python, right? But if you want to create a custom class, a class for yourself, right, a user defined class, then what you will do, you have to first create an empty object. This is how an empty object is created, right? We have seen it multiple times, right? So how to create an empty object? Suppose my object name is object 1, right? How to create an empty object? We just need the class name and small braces, that's it. An empty object is created. If I will print the type of this empty object, see, I will get student, right? Why this main dot student? Just leave this main part for right now. The class type is student, right? So this is how to create an empty object. So creating an object. To access any type of attributes inside a object, inside a class, right? Inside a class, what we do, attributes. So what we do, we use dot operator. Suppose I want to access this name. What I will do, I will use object one dot name, right? So this is how you will access a attribute, right? This is to how to assign the value to attribute or to print the value of an attribute. What is the name? Right? Yeah. Okay. Now, how to access this university and marks? Both all are same, right? Now you cannot use something like this object one dot marks, and you cannot assign data like 10, right? You will get some. Okay, let me print the values one dot marks and see we are getting 10. So it is of type list. We have created a marks of type list, but we are providing a data of type integer, right? So if I will print the type of this particular marks, see what we will get. We will get of type integer, right? Because we are providing an integer type data there, right? We have seen this that providing a list or creating a empty list doesn't ensure that your variable is a list, right? The data type of a variable in Python is always determined by what type of data that variable is storing, right? So it is storing a 10, the integer value. That's why we are getting integer. Okay. So this is how you can access a particular variables. If you want to store it in a list form, just do no, not like this. Just use dot append 10. In this case, you will get it a list type, right? If you will print the value, so it is a of type list, right? Now, guys, so what is this object? What is this obj1? So we have seen that we are using this a to create an integer. We are using this b to create an integer. We are using this obj1 as object, right? We are using this obj1 as object to create a particular object of student class, right? So what this is doing, this is using our student class as a blueprint, right? So what happens? Suppose right, consider this as your memory, right? A block of memory in your RAM, right, where your code is going to store data. What we got here, we have a attribute to store name, we have an attribute to store university, we have an attribute to store the marks of students, right? How this particular memory is created? This particular memory is created with the help of an object. We have some object, right? And with the help of the blueprint of this class, right? So you can say that object is the implementation of a class and class is the blueprint. Now, there are some more theory parts, right? One of the theories that this particular object, this particular class, it is known as custom data type or user data type, right? A class and object, these are known as user data type, right? Integer, integer is a predefined data type in Python. Python define integer for you. Python define floats for you. Python define set, list, or Python define string for you. But this particular student, this is also considered as a data type. But this particular student is created by the user. The user has created this student, right? It is a user defined data type, right? So suppose, so okay, so let's revise what we have covered till now. See, how to create an integer? We just do b equal to 10 because integer is a Python defined data type, a predefined data type. The Python interpreter will create a memory for you in the RAM, right? But you want to create a variable for a student class. In this case, the variable is known as object, right? So if you want to create a variable for a student class, the interpreter will need a blueprint to create the memory, right? Interpreter will not go like this and create some create some variables like name and string and some more a list, something like that inside that memory, right? So interpreter is not going to do that. You have to provide a blueprint. So class is the blueprint. Object is our variable, the implementation of that class, the implementation of that memory, right? Okay, one more thing. If some memory is created, right, to store integer, how you will reference this memory? You will reference this memory as the memory name, as the variable name. If this is a b equal to 10, how I reference this, how I will use this particular value using the variable name b, right? Similarly, if suppose a particular memory is created for an object, right, and there are attributes inside this memory and multiple attributes, and there are, suppose consider that there are function methods also. Just leave the method part for right now. Okay, how do you access, how do you reference this particular memory block? You will reference it using the object name, using the variable name only, right? No difference. Okay, now this whole particular block is your variable, this whole block is your variable. Okay, how to access this particular attribute separately, how to access this attribute, how to access this attribute? So first of all, you will access the whole memory, the whole object or the whole variable using the variable name. Then you will use dot operator to access a particular attribute or particular method inside that memory, right? Okay, so up till now we have seen how class will be created, how memory is handled, how interpreter will use the blueprint to create a class, all these things, right? Okay, so let's talk about some. Okay, now suppose I want to create some object 2 of student class again. Now as you can see that you can create many variables for an integer, right? I can create a c equal to 20, I can create a d equal to 30. All are variables, all are objects of integer class only. Similarly, you can create multiple objects for a class, right? Class is just a blueprint. Okay, so class is just a blueprint. You can create multiple objects from a class using that particular blueprint, right? These objects are somewhat identical in nature, right? All three are using the same particular blueprint. The same blueprint are used by all three. Okay, now yeah, just notice one thing. What happens if I see I will print the name using this particular variable? Yeah. So just okay, just observe what I'm going to do, right? So we have according to the blueprint, we have a variable named as name for each and every object because it is in the blueprint of the function class, right? It is in the blueprint of the class, so each and every of one of them are getting a variable name as name, right? Okay, now suppose this is object 1, right? And suppose this is object 2, right? So see, I have provided some values to object 1 name. See, I have provided the value to object 1 name. I have provided the value to object 1 dot marks, right? But I don't have provided the value to this particular object to name, right? So let's see what happen if I will print the particular value. See, I'm not getting anything. It's just an empty, right? It's particularly an empty string. Nothing is there, right? Because we have not provided any value. Okay. Now, guys, if you have any doubts till now, let me know. Otherwise, we are going to discuss more about class and objects. Okay. Okay, so let's see. Now, if you will notice, let me first of all let me print the ID of this object 2 and the ID of this object 1. We got two different IDs. So from here we are clear that both are acquiring different memory locations, right? Okay. Now, if I will check the ID for object 1 dot name, I will check the ID for object 2 dot name. Then again we got two different memory locations, right? Two different memory locations where it is holding the values, right? Because both a name, the name for object 1 and name for object 2 are at two different memory locations, right? Okay. So now there is one more thing. You can access these particular attributes using the class name itself, right? I can access, suppose, instead of creating objects, I want to assign the name of the student as, suppose, uh, student 1, right? Now let's see the output. See the object 2 dot name. At first, object 2 dot name is printing just a empty variable, right? Nothing is there, nothing was there. But right now, object 2 is printing student 1, right? We have provided the student 1 to this class. We have provided the value to this particular variable, but object 2 is printing the value of this variable, right? Now, let's try to remove these also and let's see what we are getting. So it is again printing student 1, right? This particular name is again printing student 1. This particular name is also printing student 1. And okay, let me comment out these two. Okay, as you can observe, the ID, the memory location of both these name variables for object 1 and object 2 are identical, are same, exactly same. If I will create some object 3 for student, right? And if I will print the ID of object 3 dot name, then again you can observe that all these three memory locations are identical. So what we conclude from here, right? If there are multiple objects, right? If there are multiple objects, all these objects, okay, not these variables, right? Okay, all these objects are accessing the same name, only this particular name inside the class. All these objects are accessing this class only, the name of this class, the name variable of this class. See, if I will, okay, let me print all of these together. And let me print the ID for the memory address of the variable student.name. So what is this student.name? This is this particular variable, the variable of our class, the attribute of our class. And by using dot name, we are trying to access the attribute of our objects, right? But let's see what we get. So all the four memory locations are exactly same. It means this particular variable is shared by each and every object and the class itself. Now, what is the meaning of sharing a variable, right? Suppose, mm, okay, instead of this, let me do student. Now, I have made one more change, right? What I am doing, I have updated the marks of this student, right? There is one more variable, right? There is one more variable that is a list, right? It is holding some value. So I have updated the value of that list only, right? The list of this class, I have updated the value of this list. See, the list is updated to 10, right? Now, what happen if I will print object one dot marks 0? Yeah. See what we will get. We will get the exactly same values. So all these objects are sharing this list only, right? So there is a problem. We are creating object 1, object 2, object 3 to store student data, right? And it is not, I mean, it is not possible that all three students are having same name and all of these three students are having the same particular marks, right? So these things cannot share data. We want a dedicated name for this particular object. We want a dedicated marks object for this particular object, right? We need a dedicated name variable for this object. We need a dedicated marks for this, also a name for this one and a marks for this one, right? So now, so I think it's pretty clear, right, that what is the problem till now, right? Each and every object are sharing the same data, same memory location. So how come they are sharing the same memory location? Let's talk about that. So we have a class. Okay, let me show you if possible then. Okay, stop this one. Let me add some checkpoints. Right. Okay. Okay, so see what we have up till now. There is a class, right? Nothing is created there, right? There is nothing created, not in local variables, not in global variables up till now, right? Okay, leave this watch panel. Okay, observe this one, right? Okay, see what we are trying to do. We are trying to provide a value to this name, right? We are trying to provide a value for this name. See, we didn't get anything here, right? But inside this class variables, inside the student class, see what is there. Inside the class, we have a variable name, and the value of that name is only one, nothing else. That's student one. We have just provided that. We have provided the value to this marks, right? But as you can see, there is no memory is created for this marks and name, but we are storing some data. No memories are created there, but we are storing some data. How come that is happening? So your particular class, right? The variables, the attributes which are defined for a class, The variables or attributes which are defined inside a class like these name, university, and marks. These variables are defined for a class, right? So they got their own memory space, right? And data is stored there, some number and some name, whatever that is. They got their own memory space and some values are stored there, right? Now we are going to create object one. We have created object one, right? Now, guys, see, inside this object one, see, we have a class student class. Okay, let me just end this only. Yeah. So see, we have a separate memory location for a class variables. We have separate memory location for class variables. We have separate memory location for object one, right? And object one is having the value marks as 10, university, sorry, name as student one. Now, the print statements are there, just leave these statements. Now, again, we are creating an object two using student, right? What is student? Student is the blueprint. If some values are present inside your blueprint and you are going to create a memory from that blueprint, that memory will also contain that values, right? This is the meaning of a blueprint. If you are going to create a particular memory from a blueprint, the values will be also there. Values will be also copied, right? Okay. So what we got, we have different values, right? Now we are going to create object 2. See, object 2 is created. Inside object 2, again, marks is 10 and name of student as 1, right? We have created object 1. Now again, we are trying to create object 2. And inside this object 2, again, the values will be there, the copied values, right? Then again, we are trying to create object 3. Inside this object 3, again, the same thing will repeat, right? And we will get the print the values and all this. Yeah, we will. So we are getting the same memory address for all these name variables. All these name variables are having same memory address. And why this? Because instead of creating these particular values, these objects, these objects are sharing this particular variable. These objects are sharing this variable, right? That's why we are getting the same memory address. Now, what we have, all the values are same and that's it, the code value, right? So this is how somewhat memory class memory is created, right? So if it's difficult to understand up till now, then just I would say that please leave every topic up till now. From now we are going to implement it, right? So just watch some basic theory and we will start implementation, right? So there are two types of attributes in Python, okay, in Python class. One are known as class attributes, right? A particular class attribute is shared among different objects, right? If you have three objects, all these three objects will share the same attribute, right? All these three objects are sharing the same attribute. Okay. Now, if they are sharing the same attribute, then this value of this attribute is shared by all of three, right? If anyone can change the value, the changes will be reflected in all the objects, right? Now, there are someone a more different type of, you can say, particular attributes, one more type of attribute, that is object attributes in Python. These attributes are dedicated to an object, right? Okay. So what I mean is that, see, this particular attribute is local to this object, is only defined, is only operated by this object only. No other object can access that. It is not allowed, right? Because it is, you can say that, defined only for that particular object. This attribute can be defined for this particular object only, right? So let's see the implementation then. Okay, so we have seen that we have two different types of attributes. So up till now, what we are seeing, that these are known as class attributes, right? And class attributes are shared among objects. So you cannot put a name of a student, or you cannot put the marks of a student in class attributes. Why? Because marks and name of the students are unique to that student, right? The name should be unique to that particular student. So you have to create a object attributes for this name and marks. You have to create object attributes for this name and marks, right? Now, okay, just comment out all these. Let's comment out this one block only. Okay. Now, suppose I am creating the details of student one. For creating the details, I will need the blueprint of student class. Suppose I am creating the student two, right? Okay. Instead of creating a empty university, see, university of all students are going to be same. The university name of all students are going to be the same, right? Let's name it as my university, right? So if I will print student one dot university, we will get the value as my university. If I will print student two dot university, I will get the value as my university. We have seen that this, right? Okay. So right now what we have, we have a class. This class is, so this particular class is holding an attribute, right? Attribute for university, right? Okay. We have two different objects, object one and student two, right? And both of them are accessing the same university name, right? So it is clear up till now. Okay. So now after this, so we need to store student name also. We need to, right? Okay. So we need to store student name and other related details, right? So how to store those details? If you want to create any particular object level attributes, object attributes, so this is how you will create that. Just write dot name and it will create a object attribute for you. Right now, if I will print, it will print hers. That is, it is a object attribute. What we have just done, we have just created, we have just created an attribute for object one, right? Now see, if I will try to print the student two dot name, see what we will get. We will get an error. And why this error? Because we have not, okay, okay, yeah. Why this error? Because we have not created any attribute for this particular object, right? We have not created any attribute for this object too. That's why in this case we are getting an error, right? So let's create an object, an attribute for this object also. Okay. Now in this case we won't get any error and we have a name of two different students, the attribute of two different students and all these things, right? So this is how you can create an object with their attributes, right? So these are object attributes. Okay. So we have class attributes and object attributes. If any one of you have noticed that this is not a very good way to create object attributes, right? And why this? See, if you are creating, if you have provided the user the opportunity to create object attributes, someone is creating student one dot favorite food, some object like this, right? Some attribute like this, favorite food named attribute, right? and just give it a value, and someone is creating, suppose student dot address like address one. Okay, so see, it will create some inconsistent data, right? It will, I mean, it will clutter your, as you can see that you cannot operate on these objects anymore. See, this one is having some other values, this one is having some other values, and some one more values will be created, and some one more value will be created. What happened if you are trying to just retrieve data from the student, right? You are just trying to print the data of this particular student, the name and all these things you just want to print, right? So what happens, it will only print the name and the favorite food, and the student too, this object will print name, favorite food, and marks and address, all these information, right? So it is not a good way to provide to create object attributes like this, right? It is an option, this is how you can also create object attributes in Python, right? But it is not a very good way to good practice to create object attributes like this, right? Okay, so first of all, let's create a method name as create attributes, right? Now, so it is a syntax to write, there is a syntax to write methods inside a class, right? Sorry, there are syntax to write methods for a class, right? You have to provide a parameter there. It is compulsory to provide one parameter. See, if I will print like this, and if I will try to access the class, the particular function, see what happened. So I will get an error, right? So zero positional arguments, but one was given. It means that it is not accepting any arguments, not accepting any parameters, but we are providing one. So we are not providing any parameters, any arguments right now. But what is this particular argument? So how, okay, the answer is for this one is how a particular method is created. So if you are creating a method, right? So how to call this method? So this object will call this method, right? You cannot write a simple function call for a method written inside a class, right? This method has to be accessed like this. Okay, a function call, a method call, right? Okay, this object one can call this method. This object two can call this method. So how does this method will know that which object is calling this particular method, right? So what happened during a function call, during a method call, this object, the idea of this object, this whole object is provided, is given as an argument to this method. So we need a particular parameter, okay, which is generally written as self, right? You can name it anything, right? ABC or anything, but it is generally written as self, right? And if I will print C, and if I will print the ID of student one, see, in this time we won't get any error. And as you can see, both the IDs are identical. Means the student one is the same variable, the same object, which is referred to as self in this case, right? So it is a syntax. It is mandatory to provide at least one parameter in a method, in a class method, right? Method written inside a class, you have to provide at least one parameters, right? And what is this parameter? This parameter is nothing but this object, right? Okay. So we have seen that these are not a good way to create your particular attributes. Okay. So we will try to create these attributes using a function call. Okay. Now, how we are creating an attribute? We just using the object name and dot operator will create an attribute for us, right? So let's use the same method here, right? This self is our object in this case. So we use self dot. The first thing we need is name. Okay, let's create empty values right now. And we have self dot. What else we have? So we don't need favorite food and something like this type of attribute for a student data, right? We need something like marks. Let's create an empty list, right? Now, if you will see, if I will create student one dot create attribute and if I will call student two dot create attribute, see, okay, I have to print the values. Okay, we have called the create attributes. So let's print the value dot name. So in this case, I'm not getting any error. And if I'm not getting any error, it means the name attribute for this, the name attribute for this object is created, right? And the value of that particular name attribute is nothing but an empty string, right? An empty value is there. Okay. So this create attribute will help you to create a consistent type of object attributes, right? This same name and marks will be created for your student too. Okay. And the if you will create a student 3, the student 3 will also contain only name and marks, right? So it is a good practice to create a object level data object type attributes like this, because each and every object will contain the same attribute, right? If you want to access a student detail, all student will contain the names and marks as their details, no nonsense attributes like those, right? Okay, now this is again not the preferred way to create an attribute for a object, right? Now let's talk about one more concept. Okay guys, before moving forward, just take a 2 minute break, right? And if you're having any doubts, then please let me know. Okay guys, so let's continue. So Yeah. Up till now, we have created the attributes of student one. Okay, let's first of all let's check that we have already created the attributes of student one or student two or not. So there are some type of functions which are, you can say, predefined in Python, right? We have seen that sum, length, and all those functions, right? At append and all those functions. So there is one more function which is predefined in Python, right? That is known as, suppose if I want to check what type of attribute is there for this particular object. So I will use this this particular method, right? This double underscore type of method, see, it is double underscore. So this type of methods are known as dunder methods in Python, and these are predefined type, right? Already defined in Python. Okay. See, so student one, I have created two attributes for student one, name and marks, and both are empty. I have not provided any value, right? Same with the student two, name and marks for student two is also created. See why I'm not providing any value. See, if I will provide any value here, we will get that value in both the variables, right? Why? Because both are calling the same function. So that's why we are not providing any value here right now. Okay. Now let's use the student one dot name to store some value. Student two dot name store another value. Now let's again check. See, right now we have two variables, two object label attributes, object attributes with some values are there, right? Okay. So instead of calling this particular method, this dict method, let's use some proper way of displaying values of a object, right? Okay, so the first one will be, so if you will try just this print, so it will print only the memory location of the object. It is not going to print the values associated with the object attributes, right? It is not going to print name us and name Amit like that, right? It is only going to associate, it is only going to print you the particular memory addresses of that objects. Okay. So now let's create a display function here, right? Okay. Again, this function is a method written inside a class, so we have to pass self, right? Okay. Now this display function is here, right? And it is accepting an object. What we are trying to do, we are trying to just print the values of that object, right? The attribute values of that object. So we have the object, we just have to print the values. That's it. Self is the object which is calling this function, and we will just print the values. So instead of this, let's do a proper formatting. Okay. Instead of giving a print, let's do, right. Sorry. So right now what we are trying to do, instead of calling print, right, let's use the function, use the object to call the display function, right? Now this display function will print the values. Okay. So This self is containing the particular function which called this particular method. Okay, and this self dot, using this self dot name and self dot marks, we are accessing the particular attributes, object attributes, right? So you can mention it here, accessing. Okay, now I want to print the name of the university, right? I also want to mention the name of the university. So how to do that? So either you can use the object name dot university, right? It will provide you the value of that particular university, my university. Or there is one more proper way to use the uh, class label attributes, that is by using the class name, by using and accessing the class name, right? This is how. Okay, just think. Okay, let me just remove these from here. Right, so we are getting the university name. Okay, now see. Okay, similar to the objects, if I will do call this dictionary function for the particular student class, you got these many attributes, right? I mean, there are many more things, but instead of that, just focus on this university class. We have of string, we have one class label attribute, this university class label attribute, which is of type string. That's good, right? Okay, we have the value of university, that is my university. We have provided the value. We have a function create attributes. See, we have a function inside it, create attributes, right? And it is the memory address of that particular function. Each and every function and attribute inside a class get their own dedicated memory, right? Okay, see, inside this display we have the memory address, right, of the display function. And okay, just leave these things. These are some predefined things are there. Okay, just focus on what we have right now. Okay, so we can also print the attributes of the class also, right? Okay, okay, right now. So this is how we access a particular class object and object attributes. So we have something. Yeah. Okay. Now let's talk about one more concept, that is known as constructor. So up till now we have seen we have a class, we have an object, right? And we need a memory, right? Memory to store data for that object and all those things, right? Okay. So interpreter will come to this particular object. This object will check, the interpreter will check the blueprint. Then the interpreter will create, allot a memory for this object, right? This object will get a memory location. Okay. Now there is one more twist here. There is one more component which is working here right now. And that particular component is known as constructor. So when your function, when your interpreter is trying to construct a memory for you, when your particular interpreter is trying to construct a memory for you, yeah, memory for you, it will take help from the constructor, right? This constructor is responsible for creating this memory. Okay, this constructor will create a small boxes of memory inside it, suppose like a name, a university, some other values, and it will initialize those values also. It will provide some value inside this, 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 right? So okay, let me show you an example. Move all these. You only need the class, you don't need these attributes, right? You only need a university attribute and this. Okay, okay guys, so this is again a dunder method, which is known as constructor, right? This is a syntax to write a constructor, right? There is one more thing, guys. There is no return type for a constructor, right? A constructor cannot return anything. See, similar to this method, create attribute, similar to this method, display, you can return any string from inside of this method, right? Because it is a function. After all, it is a function written inside a class. That's it, right? So, similarly, but inside this constructor, you cannot return any data type or anything, right? So it is one of the, you can say, observation, a key point about constructor, that you cannot return anything from inside a constructor, right? Okay, now let's create an object. Let's print object one that let's do. Okay, now see, how does Python or your interpreter handle these commands, right? Okay, first of all, we are with the class, right? We are registering the class. Your interpreter is checking out the blueprint, right? Okay, okay. Right now we are with the class label attribute. See, before construction of an object, these are observations, right? So before construction of an object, the class level attributes are there. The class level attributes will get their memory, right? Okay. We have a class level attribute, see, university with some value. Now your interpreter will check out the constructor, right? And it is not going to execute the constructor. We are not going to execute the constructor, right? Okay. Now we are at object one. Right now, what we are trying to do, we are trying to create an empty object, object one. See how a constructor is called. As you can see from this diagram, there is no particular, you can say, dedicated constructor call. Your interpreter is calling your constructor for the purpose of creating the memory, right? So see how constructor call is made. Once you try to initialize an object, once you try to initialize, you want to create an object, at that time, what happens? Your object will create, your interpreter will automatically calls the constructor. It is an implicit call. Your interpreter is calling the constructor, right? We are creating name, we are creating marks, then we will come back to the object. Now a complete, see what you are trying to do. Yeah, you see, first of all, your compiler will come to your class. It will register your class, check out the blueprint. It will provide you a university name attribute, class label attribute with memory. Then it will register the constructor, right? Now what happened? You are trying to create a object. What type of a object? What type of blueprint? So you are trying to use the blueprint of student, right? You are trying to use the blueprint of student. Now To create this particular memory in RAM, what your compiler is doing, what your interpreter is doing, it is calling the particular constructor, and it is the job of the constructor to create memories, right? It is the job of the constructor to create different memories. We have just seen that these two self.name and self.marks were created, right? And after creating this memory, the constructor or your interpreter will hand over this memory location to your object. Now your now creation of an object is completed, right? Creating an empty object is now completed. Okay. Now, after this, after completing the object creation, we are just printing the values. That's it. See, the values are printed, and that's it. I mean the name of the attributes. Okay. Now, guys. So what we have seen that, okay, it's not the example is not here. Create this. Instead of using student, let's use student my student. Okay. Why I'm using my student? Because we have one more class with the same name, right? Second. Yeah. Now, if I will create object 2, the same function will also repeat for object 2, right? We got some dedicated memory for object 2 also, right? Now, as I've told you that this particular constructor is a method in itself. It is a special type of function, right? A reserved function in Python, okay? So and one more thing, it is compulsory to provide a parameter in any method creating inside a class this particular parameter, right? Because this parameter is holding the object you are which is calling this particular function, right? Now, if it is a function, it can accept many more types of, sorry, it can accept many more types of parameters, right? Suppose I want to provide a name, I want to provide some marks of English, I want to provide marks of, suppose, Python, right? I want to provide these marks and I want to provide the name, right? Okay, first of all, let's copy this one. Okay. So this type of constructor without any parameter, without any values are known as default parameter, default constructors, right? Okay, this is known as parameterized constructor. Okay, now what we have right now, we are passing some values here, right? Okay, and we got some error in this time because see, these are expecting some values. See, three required positional parameters argument, name, English, and Python are expecting some values, but we are not providing any values. See, only this line is calling the constructor, right? We have seen right now that your interpreter will call the function, the call the constructor whenever a new object was created, right? So this line is only calling your particular constructor, right? So you have to pass the values here only. Suppose I want to provide the values as and some 90 and some 98. Okay. And again, I want to provide some values like this, right? Now there is no problem, right? Again, okay. So again, see the values of name and marks are empty here because I am accepting the values here, but I'm not assigning the values here, right? So I have to first assign the values. Okay. Now start. Okay. Instead of doing this, let's provide it with this. Yeah. Now see the values are there, right? Now guys, See, the name of these variables are exactly same, right? So how does Python differentiate which is, I mean, which is our name parameter and which is our object? So whenever you are using self dot name, the Python is accessing the particular object level attribute name, right? That object level attribute. So it is there. There will be no ambiguous. You can say function call. There is no such thing, right? No error you will get. Okay. So Python will know if you are using self dot any attribute name or any method name. Python will know that you are trying to access the attribute or the method of this object only, no other attribute, right? And this name is used as a local variable name, right? Now I want to create a particular constructor, right? So inside Python, you cannot create multiple constructors, right? You cannot do like this. Suppose I'm using this only. So in Python, you cannot do this. You cannot create multiple types of constructor, right? Only this constructor is running right now. It is only executing. Okay. You cannot call this particular. See, if I will remove all the values, see what we will get. I will get an error for this particular constructor call, right? This constructor call is good. Okay, there is no problem with that. But I will get an constructor call for this one. Why? Because there must exist only one constructor inside a class in Python, right? Okay. So suppose you want to modify your particular class, your particular constructor to accept all these kind of values. So we have seen this, right, with the use of default constructor, right? For default constructor, I will provide it with the null values. With the English, I will provide none. Python, I will provide none. Let's see. In this case, it constructed us a particular. Okay. So it has constructed a particular object 2 with no values, right? So as you can see, the marks is containing none values. So it is not a very good practice to provide any none values, right? So let's again work with this, right? Fix this. So suppose if English. So what's it this if condition is doing? It is trying to check that if English is containing some value or not. Suppose we have created, first of all, we have to create a marks here, right? In either cases, the object should contain an empty marks list, right? If English is there, I mean, if the value of English variable is there, right? So we want to append that, right? Into list. And if the value of Python is there, Python variable is there, then again we want to append that, right? Okay, now let's see. See, in this case, we got a empty marks, right? And in this case, we got the marks with some values. So this is a correct way, a preferred way to define a constructor, define objects, to define object level attributes, to define class level attributes. Okay. Now, guys, we are talk right now. We are talking about dunder methods. Okay. So there is one more type of method that is, if I will use the name is object one. So we have seen that if I will print it like this, I will get the particular memory address, right? But I want to create a function which will handle this, right? If I will print an object, it should print the particular values of that object. So we have one more predefined method, right? That method is known as string method, right? str. So what happened whenever you are trying to print an object like this object by default calls this string method, right? Now let's use this string method. So what this string method is, it returns a string. Okay, it is accepting an object and it will return a string, right? How? Let's create that string, that information string. Let's create that. So it will return this information string. So what we are trying to create, first of all, I want to display university name. I have done this one already. Okay, so I want to display university name. With this, what I want to display, I have marks, name of the student. What else I have? I have the marks obtained by the student. With all of this, we have to provide a /n to change the line, right? Now let's see what happens if I will print this. You see, the values are printed there. With the use of this print, we are printing the values of the object. There is no need to provide any custom display method for this one, right? It is already working without using the display method with the use of string method, double under string, right? Okay. Now let's see, just format this. Okay. Now observe the string method. It string method always return a string, right? You can return anything, any string of your choice. Like you can return a string of information of object, something like this. So it will print the information of the object. So it will return the information of the object because you are trying to print the object, and this object by default will call this string method, right? Okay. So instead of that, what we have done, we have constructed the information, right? Using this f, we have constructed the formatted instruction information. We are trying to pass that information, right? So it is printing the particular value of the object. Now see, it is not only created for object 1, it is also created for object 2, right? See, it is also created for object 2. So it is, these are some good practices to provide these types of methods inside of your class if there is any requirement, right? Okay. Now we have seen abstraction, encapsulation. So let's revise those. This is a my student class. This student class is holding a university attribute and two different methods, right? So it is in encapsulation. All these methods and attributes are binded inside one single name, one single class, right? Now, what is abstraction? So see, if you have implemented the class, right? If you have implemented the class and there is some user which is using this particular class, so there is no need for the user to understand how this class is implemented, how this print statement is implemented, how are these objects were created, is there any constructor or not, are there any default or parameterized constructor. There is no need for the user to get this information, right? So this is abstraction, right? We are abstracting the implementation of the class. We are only providing the user the functionalities which he wants, right? Print statement. If you want, you can create a pass or fail method here, right? Okay, so this is abstraction. Now one thing that is polymorphism, right? So the definition of a polymorphism is existence of a message in more than one form. Okay, existence of a message in more than one form is known as polymorphism. So let's discuss about that theory of polymorphism. And we are using polymorphism since like yesterday when we have seen the default parameters, right? We are using polymorphism again and again, right? So let's see what polymorphism is. Okay, suppose you have a function. Okay, let me create the example with this. Okay, I have a function. Let's not create this. Let's use the real ones. Consider this function, right? So we have a function. Okay, now this function, all these four function calls, all these three function calls, all these four, five, six function calls are made to the same function. We are calling the same exact same function, right? But with different values. So how is it possible, right? So what happens? You have one function. There are multiple copies of this exact same function exist, right? And why these multiple copies? So I think there are four attributes, right? Yeah. So there are four different copies, right? Three. Okay. There are four different copies. And why these copies? So, so there exists one copy of function, one copy. What this copy will do? This copy will run if you will provide all the four attributes. If you will provide all the four attributes, this one copy will run. See, we are providing all four attributes. The same function is running, right? The same function is running. We are getting all the values. The same function is running. Now, there is one copy. This copy will run if you will provide only three values, right? So these two function, this function call and this function call, both of them are calling this particular copy, which accepts only three attributes. Okay, this one function call, it runs if you will provide only two attributes. See, we are providing only two attributes and the function is running, right? We are providing only two attributes and the function is running. If I will provide only a single attribute, then also the function will run. See, for the single attribute, the function is again running, right? For the single attribute, the function is running. Sorry. Yeah. So this copy will run if you will provide only a single attribute, right? So all these four copies are there. Okay. But all of them are a single same function. All of them are same function with the same function name, that is sum4. All of these four are this same function only. This function is executing with different behavior, right? Consider this function as a message. This message is showing different behavior for different types of input, right? This function is showing different behavior for these different types of inputs, right? So it defines the, you can say, the property of polymorphism. Existence of a message or a function or an attribute or anything, existence of a message, right, in more than one form is known as polymorphism. So this particular function is existing in more than one form. See, it is existing in more than one form. All of these four are the same function only. All of these four are known as sum4 only. See, we are using only the name sum4 to execute all of these four. Only the number of arguments are deciding which copy to call, which particular instance, which particular copy to call, right? So we have seen polymorphism. Now think of polymorphism for this constructor. This constructor is again following the concept of polymorphism, right? So there exist, how many values are there? Okay. So one constructor call is made when you will provide all three values, right? One constructor call will be made if you will provide only two values. One constructor call will be made if you will provide one value. One constructor call will be made if you will provide no values, right? See, we are not providing any value and the constructor call is valid, right? We are getting the input, sorry, not input, we are getting the constructor call is there, right? And we are getting the values. Okay. Now This is also not, this is also working. We are providing three values, right? If you will provide two values, then also it will work. If you will provide only one value, this will also work. Okay. So the this particular constructor is also displaying the property of polymorphism, right? Okay. Now let's see more about this class and some good practices about how to create a particular class. Um, okay, let's modify this one only. Let's create a function, right? Let's name the function as take inputs. First of all, we have to pass self, right? What this function will do, it will take inputs for the particular variables from the user. Okay, we have not markdown self dot marks. Okay, there is no need to remove anything, right? Okay, just let it display all these things only, right? Okay, the name of this is my student. Okay, remove this, correct this one also. Yeah, think everything is okay. Remove the flags. Yeah, it's good to go. Let's create a user with some value, and let's not create a user with any values. And let's create call this function take inputs, right? Okay. See, our object one is already created, right? Now it is asking me for to enter the name of the student. That will be, let's take it as Amit, right? Okay. It's asking me for the marks of the student. Let's take it that as 12, and we are getting an error because of, okay. Instead of taking inputs, we have to do dot append. Also have to, for this one, we have to do dot append, right? Not zero. Make this one marks 12. Let's take it as 13, right? See, the details of student 1 is here, right? The details of student 2 is here, right? With the values we have just entered, right? Okay, so it is taking the values as string. Let's convert that to int only. Not int, let's convert that to float because it may contain some decimals also. Float. Okay. Okay. See, if you want to create a empty list which, which may contain some float value, so you can create that like this, right? So it is somewhat like you are trying to create an empty list which may contain float values, right? It is not binded to that. We have seen this multiple times, right? But it's just you can consider a good practice. That's it, right? Okay. Now, so this is how we are taking input in an object, saving inputs for an object, right? Okay. Now, let's compare if let's define a winner, right? And what is the use of this winner method? So let's see some ways to write a method, right? First of all, let's create a description. Inside this triple quote string, we use to describe what is the role of this function, right? So this function, not function, this method, just the naming convention, this method will be used to print the winner compared on the basis of marks, right? So what we need someone, right? So what is this self dot marks? So the object which is okay. Let me first show you the object call. Suppose I want to check the winner between object one and object two, right? So how we are calling this winner function? We are using object one to call this winner function. So this self will be our object one, right? We are also passing object two as a argument. So we have to create a parameter here named as object or any name you want, any name. Let's do it as student two. Let's instead of self, let's use student one, right? Use these names here. Okay, okay. We are using student one and student two, right? Okay. So what this student one is going to contain? This student one is going to contain this object. This student two is going to contain this object two, right? So we have a sum of marks of student one. Let's create the sum of marks of student two. Student two dot yeah. Did we use the name anywhere else? No. Okay. Now, if someone is greater than sum 2, then let's return a particular string. Winner is student 1. Now elif sum 2 is greater than sum 1, return winner is student 2. And in else condition, let's return the- okay, that's it, right? Now these are returning some strings, so we need a variable here, a result variable here to catch that particular string, right? And now let's print this particular result variable. That's it. Let's try to execute. Okay. We are getting input inside this one. Okay. Not like we have to just remove this one right now. Yeah, it's good to go. So the second name that's let's give it Amit, right? Okay. Instead of just returning student one and student two, let's return some uh, a good information, right? Instead of just return student dot name, student one dot name. For this one, let's return student two dot name. Okay. And let's what is the mass 90 and 98. So in this time, let's give it 9 and 89. Okay. See. So in this case, first the take input will run, we got the inputs, right? After that, this particular function call is made, right? This particular function call is made, the function will run and it will return the particular value to the result. We printed the result, winner is hash, and after that it is printing the values of related to all this object. Okay, so up till now, what we have up till just covered that we have seen a constructor, a default constructor, we have seen parameterized constructor. Now, up till now, we have seen the proper definition, the implementation of polymorphism. We have seen how to take user input. We have seen that how to take user input into objects, how to use a string method, right, to print the values. Now, as you are seeing that we can call a method using one object, right? Suppose if there is a requirement, right? Suppose if there is a requirement, I want to create a object tree, right? Using my student, I want to create a object tree and I want each and every data from object 1 inside that object 3. See, this object 1 is creating some data, right? I want this object 2 data inside my object 3. Okay, if I will execute this one, mm, mm, if I will execute this one, it will be executed. If I will print the value of object 3, you can see that we got all the values, right? How this marks obtained was run. We have created in marks obtained. Okay, oh, this marks obtained. Correct. Yeah. Okay, guys. So as you can observe that this implementation by using this object call, right? How this object is created is, I mean, how this object 3 will get the copy of object 1. So the name of the university is well and good. The name of the student is taken as university and my university. The name of the student is taken as hers. Again, we have two variables for name of the student and we have two variables for marks obtained. One is showing me 98 and another one is showing me marks obtained, that is empty for this one, right? And this name of the student is empty because of there is no name of the student for object 2. So this is not a good way. You can see that you cannot create a copy of one object using just like this, right? So what is this? What is particularly this is? This is an object call. This is an constructor call, right? So you have to create a constructor to handle the copying of an object, right? So instead of these things now, as I can say, I told you that there exists only one constructor inside a class, right? So this time the type of constructor we are trying to create is known as copy constructor, right? Now how to create this copy constructor? Define, initialize with this self what we are taking with this object 2, object 3 what we are taking object 1, right? Our main object which we want to create a copy with, right? So let's name that as parent, right? Okay, so we have two options, right? First of all, let's use from copy into deep copy, right? You can either do self is equal to deep copy parent. This will work fine, right? Now, as we have only a object receiving particular constructor, so we cannot call this type of object, right? This type of object creation, right? Okay, let me first run this block. Yeah. See, we are getting an error for this type of objects, right? Why? Because we cannot call this particular constructor, right? Because we right now we have only one constructor, and that is copy constructor. There only exists one copy constructor is there, right? Okay. So let me comment out, delete all this, right? Delete this, no error. We just want to, I just want you to show how this works, right? See, mm, okay, so no attributes were created using deep copy. So let's create the attribute one by one then. Okay, guys. So deep copy will create the attribute. Why we are getting an error, guys? Because there is no object one existing right now. Okay, there is no object one right now because we cannot, because there is no parameterized constructor there exist there, right? So let's create a constructor which will handle copy, parameterized constructor, and default constructors all at once, right? So this condition, let's create. So define initialize. First of all, we have to receive a self. Let's receive name. Let's receive marks for English. Let's receive marks for Python. We have right. And let's receive an object, parent object. Let's take that also as name. Now, see how we will implement this. First of all, let's check if there is any parent object. If there exists parent object, then we have to perform a copy. So how to do that? We can do that using self equal to deep copy parent object, right? Okay. Now, if there is no parent object, it means we have to perform these operations, right? Okay. Now let's see. That's well and fine. All this will work. See, the values of objects were created, and if I will try to print the values of object 3, see what we will get. Again the same condition, again the same error. I mean, it is not an error, but this is how the memory is copied inside there, right? Yeah. So this is how memory is copied inside there using this deep copy. So we have seen that deep copy works for nested list, nested dictionary, and nested tuples, all this. But see, you cannot use deep copies in these types of scenarios, right? Where you have to copy a particular object into another object, right? Copy the data of an object into another object, right? So instead of this, what we will do, see, you cannot use a deep copy, right? In other languages like in C++ or in Java, there is a similar implementation like a deep copy, not exactly same, but there are similar implementation using pointers and all those, right? But in Python, it is pretty simple. Just use self.name and what you want to copy. You want to copy the parent object, right? So parent object dot name, and instead of just assigning it like this, here you will use deep copy, not with the whole object. Okay. Then self.marks deep copy parent object dot marks. Now let's see the result. Okay, let's compile this one. Let's compile this one. Yeah, yeah. So in this case, see, we have Okay, we are again getting the values of the parent object. The object we have passed is object one, right? Yes, we need this to copy this, the implementation of this. Is there any problem? I have self.name, self.name, return info, and if I will print the dot name of this only with this dot name, yeah, okay. So guys, we are getting an error. I mean, not an error. Memory copy issue here right now. Okay. So what are these memory copy? Okay, let's first discuss about these memory copy. Right. It's already done, right? Okay. Let's only discuss about how this memory copy is working. Right. We have a class. Right. We have created multiple objects. Object one, object two. Okay. Now what we are trying to do? We are trying to create this object three. Right, we are trying to create this particular object 3 with the values of, suppose this is our object 1, so we are trying to create this object 3 with the values of our object 1. Right, we want each and every only the value, nothing else. Right, see what we are trying to do, we are only taking the values. Right, object 1 values dot name, object 2 dot marks values, only these, nothing else. Right, but instead of that, if I will print the dictionary, yeah, instead of this, what we got, we get inside the name, we get a particular object itself. See what is happening. See, this is our name attribute. Inside this particular name attribute, we are getting this whole object itself. That we are getting the whole object itself, not the object name. We are getting the whole object. That's why when I will print only the name value, we will get the particular value of that object. Right. So instead of a particular object, we are getting the whole. Instead of the particular name only, we are getting the whole object in this case, right? So this is how this memory copy is working, right? So this particular type of, because we have to create a particular type of constructor to handle these scenarios, and that particular constructor is known as a copy constructor, right? This is not an implementation of copy constructor, right? You have to implement that on one only. Okay. So up till now, if you have any doubts, then please let me know. Otherwise, we will end the session. Yeah. Okay then, guys.